Let's go to question number 60, permutation sequence. This is hard question. Let's get into it. The set 1, 2, 3 to the n contain a total of n factorial unique permutations. By listing and labeling all the permutation in order, we got the follow sequence for n is 3. Okay, this is the permutation n is 3, n is the number of digits, so this is 3 digits, so this is the in order. Given n and k, return the kth permutation sequence. Let's check with example 1. Example 1 is n is 3, the 3 digit, and the k is 3. So it will return 3 is 2, 1, 3. How we gonna do? Okay, first let's start with the proper solution. Some of the guys already solved the question. Name is the next permutation, that is the medium question of lit code. If we do not still solve it, please check my YouTube channel because I already uploaded it too. Okay, we also use that one. So the generate 1, 2, 3 first. This is first, and then generate the next permutation, and then next and next two case we able to return this number. But as you guess, time complexity is really terrible. So we need to make the better solution. To do this, first we need to find the pattern from the generated permutation. Okay, let's check one by one. This one is n is digit is 3 digit, and then we need to find the 3, right? So this 3 digit we can make the permutation, number of permutation is 3 factorial, right? So this one is 3 multiply 2 multiply 1, so this is 6. The reason is 6. Why the permutation number of permutation is 6. So okay, let's find the pattern. How many 1 in here? There are 2, right? And how about 2? 2 also 2, 3 also 2. So we can divide the 3 group. 3 group is the same as the n group. That's correct, because n is 3. If this is 4, we are able to divide 4, right? And then okay, now we find the pattern, and then can you find the number? Can you generate the number without making one by one? Yeah, that is our goal. So okay, let's think. So now we find out how we can able to check the 1, how we can make 1. That is maybe, I think that is first is the we know the factorial, 3 factorial, divide the 3 group. That is we able to say n factorial divide n, right? So in this case it changes. This one is the same as n multiply n minus 1 multiply n minus 2, right? So we can delete this one with this one. So, and then this one is the n minus 1 factorial, right? So we replace it to it. Now we find the current number, and then this is all. So if we divide this one with kth, actually it starts with 1, so we minus k minus 1. Maybe we can find this number. Okay, let's calculate it. This is 3, so 3 minus 1 divide 3 minus 1 factorial. So this is 2 factorial, this is 2, so finally 1, right? So can you put this one is here directly? So answer is 1? No. This one is to indicate the index. So first is the 1, so we can make the nums, and nums has 1, 2, 3, and then the index is 0, 1, 2. At that time that this is index 1, so return 2. So now return 2. And then now we have the 2. This is n is 2, right? And then what is k? K is a reminder of previous calculation. So in this case, this is the reminder is 0. So now k is 0. So k minus 1 is minus 1, and then n minus 1 is n is 2. This is 1. So this one is the 0. So next 0 is the 1, right? So it is going to here 1. And then again the last is the 1. 1 is the next. Minus 1 is device 1 is 1. This is 1, 2, 1. And then last is, okay, last is the n is 1. So this one is 1 minus 1 is the 0. So we able to get the first one. So final is 1. But as you see, this is a little bit weird. The reason is we cannot duplicate this one. So we missed one step. One step is if we pop 2, we need 2 popping problems. 2 did not use duplication. And then next 1 pop is the 3 left. So finally 0 is this one. So finally is 2, 1, 3. That is this one. What we're looking for. That is make sense. So we implement like this way. So this one is a little bit, little bit, what can I say, easy to confuse. So this one is just the denote the start from 1. So first I will deduct k minus 1. That is the more easy to understand our approach. Okay, let's implement it. First I need to output as array, and then finally I will get each number as string, and then finally I will combine to 1 to reduce time complexity. And then I will make the factorial array, and then initialize with and n, because to reduce we can also use the factorial function provided by Python, but if we use it in iteration, it also takes the several time complexity. So to reduce it, I will make the factorial array and then get them one by one. If we do that, even we used a little bit more space complexity, but we can make time complexity is constant time. So first we make the factorial. We make only the n. N means the n minus 1, because we need only the n minus 1 factorial, right? So okay, factorial I is factorials I minus 1 multiply 1 I multiply I. Then we can make, now we have the factorial array, and then we will reduce k minus 1, and then for I in range to start here, first is here to start n and send it to the 1, and then reduce 1 by 1, and we look, let's make index. First the mod is the index, right? And then reminder must be going to k, and the mod divide 1, and then factorial I minus 1. And then, okay, let's output append nums index. And then we need it to nums pop index. And then return join output. Oh, I didn't make nums. Okay, I will make the string because we will join the at final stage. N is the for n in range from 1 to the n plus 1. Oh, okay. Factorial start from 1 to the n. Okay. I minus 1 is correct, and then okay, let's do 1 minus 1 is 1. Okay, looks good. Okay, let's check the time complexity. Time complexity, this one is linear time. It takes linear time, and this is linear. And then this one, the popping the specific index, it also worst case it take the n. So this is n, so time complexity is n square, and then space complexity is we use n, and then output also use n, so 3n is linear space. Thank you.